share some of what we have been doing. And also thank you very much to Professor Shi Bin and Professor Tan Chaosheng for the invitation. Well, we know for climate change, we are facing a lot of challenges. Number one is the sea level rise, which will inundate, some of our coastal areas. So for example, for Singapore, so we were told that by 2100, 1/3 of our land will be inundated. And in fact, over 1 million people will live in low-lying coastal zones subject to flooding. Unfortunately, 70% are in Southeast Asia. In addition to inundation, we do have more frequent flooding. The picture showing on the left is the flooding in Singapore only last year. And the picture on the right is flooding in Qingdao. Qingdao has been regarded as never flooded, but started to flood recently. And the reason for that is because global warming has caused extreme weathers. Extreme flooding, extreme drought, they are just some of them. For Singapore, in addition to flooding, in addition to inundation, we have other major challenges. For example, clean water, and we don't have sufficient water, and we don't have sufficient space. So for us, we need solutions for inundation, flooding, clean water, and the land. Then what are the solutions? Then after that, I'm going to explain why I have to promote coastal reservoir. Then for coastal reservoir, we have to construct a seawall. So I'm going to explain very briefly what are the options we can have for seawall construction. And then last but not least, don't forget, we still have to restore and conserve our marine ecosystem. Now let's start with the solutions for sea level rise. When sea level rise, so part of the land will be inundated. One of the solutions would be you elevate your ground. So this will be a land reclamation. So this is a good solution. But on the other hand, you will need few materials to do this. And particularly if you want to elevate your land to a higher level, so you need more few materials. But however, cities like Singapore, Hong Kong, and several other cities, it's actually difficult to get the few materials for land reclamation. And once you elevate your land, it is also more difficult for stormwater to be discharged. Once you do land reclamation, you have deprived the intertidal zone, and thus affects the biodiversity and the marine ecosystem. And the second option is use polder. Polder, in my opinion, is no difference from land reclamation, except you don't put the fuel materials all the way to the required elevation. So you have a sort of depression, a low land. So that will save you some fuel materials. But on the other hand, you have even more difficulties for the stormwater to be discharged. And you have to install pumps. You also have problems with biodiversity and the marine ecosystem. Well, since we don't have a few materials for land reclamation, but is that possible we just built a city from the seabed upwards once the seawall has been constructed? So in this way, you don't need a single grain of soil, and yet you can have a space not above the ground, not only above the ground, but also below the ground. Can this be done? Oh, yeah. In addition to the strong seawall, and you can also add in floating platforms in front, so that will create extra space. I think we have several questions. Number one is it more expensive? So I'm going to give you a cost comparison to indicate this is actually not the case. And the second question is that technically challenging? The answer is yes. But however, if you talk to my friends in China, they will say no, because they have built the 3 gorge dams, they have built many dams with a wall in the middle of nowhere. So, but however, if you construct your 3 gorge dam, you choose a location which have a strong rock. So in other words, you have a solid foundation. But however, for our seawall, which has to be marine clay on mud. So in other words, it is still challenging. Another problem is once you have a covered area with concrete, then there will be less water catchment, and thus difficult for storm water to be discharged. And again, you have deprived the intertidal zone, and thus affect the biodiversity, etc., etc. So we actually have done a cost comparison for a scheme that's a half of half a circle of artificial island. So because the cost of sand is expensive, so if we use our scheme, it is actually more cost effective. Instead of building from the shoreline, you can actually use the same idea to build the artificial island, which is away from your shoreline. Now let's look into solutions for urban flooding. Yeah, I think one of the natural solutions would be to provide sufficient catchment. So the picture showing over here is the areas of catchment in Singapore. As you can see, we have 17 reservoirs and 2/3 of the land are used for water catchment. While in many cities in China, you also have so-called wetland to provide water catchment. But sometimes this may not be sufficient. And take the Zhengzhou flood as an example. So your wetland may not be sufficient with extreme weathers. Another option would be use deep underground channels as shown in this picture for Tokyo, Japan. In addition to water catchment, to water storage, you also need the sufficient discharge channels for the water to be discharged into the sea. And if you look at our East Coast in Singapore, we do have several rivers, but whether they are sufficient, to discharge the water, and then that would be something need to be re-examined. And for that reason, the coastal reservoir idea has been proposed. So you can actually, create a coastal reservoir. The coastal reservoir itself can be used as a water catchment. So if your coast reservoir is big enough, it will provide sufficient water catchment area. But more importantly, you see, if you have a coastal reservoir, when you have a heavy downpour and yet is high tide, so you will be able to, withhold the water in the reservoir and wait several hours later for the high tide to recede. So when it's low tide, you can discharge the water from your reservoir. And since you have a reservoir, so gradually you can replace the salty water by fresh water. So gradually you can have a freshwater reservoir. So then you can have a sufficient fresh water supply for your city. So that's why we thought coastal reservoir would be a good idea. Coastal reservoir will serve multiple purposes, as I just explained. So in other words, we're actually looking for a so-called integrated solutions. So not just for inundation, for sea level rise, for flooding, but also for fresh water as well as for space. So the integrated solution should cover, number one, coastal protection, and number two, to provide water catchment for mitigating flood. Number three, the reservoir for fresh water. Number four, provide land for commercial residential development. While it is even better if you can use your dam for transport, or use the area maybe for wetland recreation. And you can also add in the restoration of a marine ecosystem, etc., etc. And you can actually use the reservoir to generate and store energy, but I'm not going to elaborate further. So through the collaboration with Shimizu Japan, we have come up with this idea. So having a coastal reservoir constructed by using a long 10 kilometers of seawall, and the seawall itself will also act as transportation facilities. Inside seawall, you can have highway. On top of seawall, you can have MRT. And since you have a strong seawall, in front of it, you can build the floating platforms. Then you can build cities, you can build residential, commercial buildings in front of it. And we actually have turned this idea into a video. Let me just share the video with you.
Floating city has been designed for Singapore, a collaboration with Nanyang Technological University and Shimizu, Japan. A 10-kilometer seawall sits across the coast and forms a protective barrier and water catchment area. The seawall also acts as a transport system with an expressway and metropolitan rail transit system connecting East and West Singapore. Using the seawall as anchor, a high-rise waterfront city comprising of commercial and residential buildings floats on a series of platforms connected to the main island. Floating city has been.
Well, in fact, this coastal reservoir is not a new idea. I'll give you an example. In South Korea, they have constructed 33 kilometers of a dike, showing in the picture, which is claimed to be the longest man-made dike in the world, which was constructed in 1991. In 2012, I had the opportunity to visit the construction of this project. And also in Shanghai, a coastal reservoir has been built as shown in this picture. In Jakarta, they are proposing to build a giant seawall as shown over here as a part of the flooding control system, because many of you are aware of the problem with settlement of the ground as well as the inundation of the land. So this giant seawall is considered as a part of the solutions. But together with this, you have to dredge the 13 rivers inside the Jakarta. So some of the materials taken out from the river and can be used for land reclamation. So in this way, you will be able to create some additional land as shown in the picture. So now let's go to the seawall construction. So if you want to build a coastal reservoir, and the key element is the seawall. In the state art report, we have summarized the type of coastal protective structures according to the materials used. You can use the fuel, you can use earth, you can use masonry or concrete, you can use the steel sheet pile or board piles, and you can use the geotextile or geosynthetic materials, and you can also use prefabricated concrete segments. Now let me just give you a few examples. For example, using geotextile, you can use a so-called rubber dam. So the picture showing over here is the storm surge barrier constructed in Netherlands. So use a big rubber dam, so inflated by water and the air with a height of 8.2 meters and used for storm surge. If it's in shallow water, you can use the gel bag, as the picture showing on the right is actually from our east coast in Singapore. Of course, you can use the gel matrix. If you don't have sand, you can use the clay and to fill the gel matrix layer by layer. And Professor Yan from Nanjing University has collaborated with me on one of the case studies, which has already been published at the 2010. And you can also use precast concrete segments. So you can cast your seawall and you tow to the place where you want to install, and then you form a seawall. And this method has also been used in China for example, for the Shanghai port. So this is the semicircular cross-section and is used for this particular project. In Singapore, we also use the same method for port construction. So give you example for the Pasir Panjang container port. So we cast a concrete box of more than 27 meters tall, and then we put in the seabed. But however, because the seabed is a soft mud, so you will have to prepare the foundation. On top of that, you have to put a rubber mount, and before you can put your concrete segments. So in other words, you have to spend a lot of effort, a lot of money for the foundation. An alternative would be to use a so-called suction caisson, to use an inverse cup, or in other words, use a concrete cylinder and use a suction to suck your cylinders into the mud to form part of the foundation. And in this way, you don't have to do soil improvement. And suction caisson is not a new idea because for offshore platform, offshore wind farm, and people has been using it extensively. But however, for coastal applications, the installation is actually more challenging simply because and the water depth is shallow and the available suction is small. So for that reason, we have done a lot of studies using a 6x6 deconsolidation model tank and use the caisson of 1 meter in diameter as shown in the picture. I don't have time to discuss our research here on suction caisson. I'm only going to share with you a case history. I shouldn't call it case history, I should call a design illustration. And because the project has not been, the facility has not been constructed yet. So this is going to be land reclamation. So this seawall is going to be used as the containment band for the land reclamation. And the water depth is up to 25 meters, as you can imagine. So you will need a very tall wall to sustain the fuel materials behind it. So this is the foundation design. So we use the 4 cylinders as the suction caisson, and then use 1 row of cylinders to form the seawall. So this is the construction sequence as illustrated in this video. So what you can do is you cast the suction caisson, you cast the top cylinders, which will be part of the seawall, and you assemble them in the casting yard, and you tow the whole structure to where you want to install the seawall. So once it's at the desired location, you use a suction to suck the 4 cylinders down. The reason why we use the 4 cylinders is for you to balance out, to eliminate any eccentricity. Then you repeat the process and you form the seawall. And once you have the seawall, you can put a few materials behind and to have your land reclamation. Of course, on top of the seawall, you can build road. And we have also done, a lot of studies on how to design, such a system and how to put a few materials. In this case, it would be mud for land reclamation. So this is just a sketch of our design as well as a land reclamation scheme. So we have developed analytical methods and also final element analysis, and for us to design and to ensure the wall will be stable and ensure the deformation will be within the tolerable limit. Well, this is just a quick introduction on the seawall. I know I don't have much time, so I'm going to move to the last topic, which is conservation of marine ecosystem. So whatever you do in the sea, and you are going to disturb our marine ecosystem. So particularly if you construct a vertical seawall, you are going to destroy the intertidal zone. And if you talk to a marine biologist, and he or she will tell you, our intertidal zone is so important because and that is a place for biodiversity, and that's a place for marine ecosystem. And that's also the area where the marine vegetations can actually sink a larger amount of CO2. But first thing is, can we recover our coral reef? And because, if you build seawall 25 meters into the sea, and you destroy all the corals in the original coastal line, in Singapore, we have experimented to artificially install marine structure under the sea, which is 10 meters tall, which has a shelf that is showing over here. So each shelf will have these grills as shown in the picture here, and the grills is covered by either shotcrete or by pure calcium carbonate. So our NTU's method is use pure calcium carbonate generated from MSCP process. I mean, in Nanjing University, Professor Tan, Dr. Pan Xiaohua are very familiar with this process. So the coral, the lacks pure calcium carbonate. So if you put them into the seawater, so the coral will facilitate the cultivation of the coral. So we have our panels installed in the so-called underwater condominiums at Singapore. So the picture showing the positions of our panel. And this picture was taken not long after it has been installed. But now I'm sure some corals has been growing on top. We also do independent experiments in seawater and below, showing some of the signs of formation of coral. And the second question is actually on coastal erosion control. You see, just show you an example. You see, you can see the comparison of the two pictures, which was taken with an interval of 1.5 years. You can see the amount of erosion within the 1.5 years, which is almost 1.5 meters. Then how to, prevent further beach erosion, or to be better still, if you can restore some of the eroded land. Our idea is to use biocement. So all you have to do, is backfill a little bit of sand, just to, recover the original elevation. Then on top of that, you can start to just spray, biocement solution. So after a while, you can see not the ground has been restored, and also the grass can actually grow on top. The one of the best features of this method is the sand will maintain its original color. So you actually cannot tell this area has been treated, because if you look at the color, they are exactly the same as the original beach. So, and after this successful trial, we are actually using larger scale and this beach erosion control at another location. The picture just show part of the field operation. Now go to
4 minutes.
4 minutes. Okay, yeah, I should be able to finish. Yeah, now let's move on to the third topic, which is construction of artificial intertidal zone. Just now I mentioned intertidal zone is very important, and yet with a vertical seawall, we will not have an intertidal zone anymore. But however, we are all engineers, so we can engineer intertidal zone, and which can be done as a part of the extension of the seawall. So when you construct a seawall, if you have a provision for artificial slope to be installed, and you will be able to install artificial slope with mangroves, with the seagrass, and that will restore your intertidal zone. Or you can also have a floating wetland, use a modularized system as shown in this picture. So once you have seagrass, you have mangroves, and then you can start to have carbon sink through a so-called DOC or RDOC process. Okay. what if you combine all the technologies together, not only you can restore the coral reef, restore the marine ecosystem, you can actually construct an underwater amusement park as shown over here. So you can have an underwater restaurant, and within your underwater restaurant, you can actually see all the fish, you see all the sea creatures, you see all the beautiful coral. This is just like an underwater aquarium. Okay. In summary, an integrated solution is the way to go to overcome major challenges in flooding, inundation, space, and clean water. So coastal reservoir will provide integrated functions for sea level rise, flood control, freshwater storage, and space creation. So methods for seawall construction and coastal marine ecosystem restoration are introduced. And finally, I would like to thank all my students and researchers, in particular Dr. Wu Shifan, Li Bing, Professor Guo Wei, he is now in Tianjin University, Chen Hao, Wen Hao, as well as Dr. Pan Xiaohua in Nanjing University for the great hard work. I also like to thank my funding agencies and industries for the strong support. Thank you very much.